All right, so as you can see, one of the things that we sometimes refer back to is there's two classifications of organic compounds that we refer to a lot with that of organic chemistry. One is aliphatic hydrocarbons. The other one is aromatic hydrocarbons. Okay, so as you can see, we're dealing with the aromatics right now. And how is it, why do we call these aromatic compounds? Yes, they're made from benzene, but why call them aromatics? Because they give off pleasant odors. That is correct. Okay, so if aromatic compounds are based off of benzene rings, do you remember what the aliphatic hydrocarbons are? We talked about rings and whatnot yesterday. Maybe that would jar your memory. Said you might have a dress ring, a class ring, engagement ring, a wedding ring. All of them may have their significance of one way or another. But regardless, aliphatic compounds are those that are straight chains and also ring structures. Now, benzene is a special ring structure. Do alkenes and alkynes, do they need to have a catalyst for them to react? No, they do not, unless it's hydrogen. The alkanes, do they need a catalyst? Yes, they do. Why would that possibly be? All has to deal with stability. What is more stable, an alkane, or I should say, what's more stable, ethane or ethene? Ethane is much, much more stable because it's an alkane and single bonded. The ethene then, of course, is an alkene, and therefore it's double bonded. So therefore, these do not need to have a catalyst, but when we look at these aromatic compounds, they have alternating double bonds in them. But this is another exception to the rule. These are highly, highly stable, and they have to have a catalyst in order to react. So we saw examples of this when we were looking at that blue box on, what was it, 328, I believe, somewhere in that vicinity. No, 359. Okay, and these are all based off of, again, that benzene ring, which has alternating double bonds on the inside. You know, it's one of them things, never trust a benzene ring, because they always lie. I told a funny. You'd never know. Okay. Okay, we're going to start the naming systems here pretty soon, and that might be why you'd want your book, because I think that's going to be coming up next. Okay, I think, nope, that slide, okay. So again, your aromatic compounds, Benzene is somewhere in that ring, and it's a special ring structure because it's highly stable, and it's a six-sided figure, and it's got double bonds inside. The aliphatic hydrocarbons is everything we've been discussing, including ring structures, just that this is a special ring structure. So when we look at something like, okay, I guess I got just a little bit. Got my stash of Coke here. Shh, shh. But it's this Coke. I don't know if you can see it. Oh, there we go. Yeah. That's, okay, got my Coke. Okay. So looking at this, oops, you can, with the coffee and with that, which one do you think would have a benzene structure in it? It's just a 50-50 guess. There's no way that you could know. Yes, I know that for a fact. The Coke or the coffee? The coffee actually has benzene rings in it because when you harvest the beans, okay, for your parents who drink coffee, maybe when they open that lid for the first time, or you just actually pop the lid open, you can smell on the coffee, you can smell that caffeine coming out of there, okay? So that would be an example of an aromatic compound. So if this has benzene structures in it, not just benzene alone, that would be toxic. We learned that yesterday. The idea when you start putting other elements and compounds on there, you alter its chemical properties to make it allowable to drink. Just like sodium chloride does not hurt us, but chlorine gas does. Okay? So with that, why does this have benzene ring structures and that Coke does not? Do you think? It doesn't have to be Coke. It could be your Diet Pepsi, Diet Dr. Pepper, regular Dr. Pepper, whichever. None of those have that in there, but yet, I can smell it. I can tell that's Diet Dew. I can tell that's Diet or regular Mountain Dew. It's still giving off an aroma, but that's artificially sweetened and possibly colored and giving off that type of an odor as well, okay? Where this is actually coming from the coffee beans, where caffeine has that special structure of an aromatic compound. Okay, so I think, is it just one more? Yes, I just want to get through this one, and, okay, then we'll stop once we get to the end there, and then we'll do some examples up on the board. So when you look at this, they have these common names. There's really, I don't know of any time frame of when that common nomenclature was devised. I would guess maybe sometime in the 1920s. I don't know. It's always called IUPAC. It's the International Union of Physics and Applied Chemists, I think is what IUPAC stands for. So once all those individuals got together across the world, they came up with a nomenclature system and said, we're going to call this methylbenzene. But up until that time, it was always called toluene. And we saw examples of that very briefly in your book yesterday. And we're going to make reference to them here shortly as well. Okay, does everyone have this information that wants it? Okay. Okay, so we're going to go and do some examples here. Did any of you see that story problem up there before I erased it? Bring back good times, physical science, force, momentum, acceleration, velocity, all that good stuff. No, okay. So there's different ways that you can depict this benzene. Remember, you're going to get really good at drawing six-sided figures. Okay, this is what benzene actually looks like. I would suggest you don't write it like this, but obviously there's nothing wrong. And notice we said these hydrogens, they lie in one plane, and you only have one hydrogen sticking out at the end. Okay, because remember where these intersect, those are carbon-to-carbon bonds. So if we call this number 1, 1 is double bonded to number 2. There's 2 bonds. And then we've got 3 here and 4 there. Carbon 2 is double bonded to carbon 1. There's 2 bonds. It's got a single bond to carbon 3, and then another hydrogen on here and makes 4. And that's why it's alternating on the inside. But a more common way to write benzene, much, much simpler, is just doing this. And then putting a circle on the inside. That means the exact same thing. And that's why you see them written in your textbook on or around page 357, 358, 359, all around those that vicinity. Okay. So notice the last thing that you wrote down was what? Toluene and was it phenol? Yes. Okay. I sure hope the sound is on. Yep. Okay. And we can go ahead and erase this guy because you're probably never going to see that ever again. Whether it's in this class. You might not even see it in college should you have to take this class. So if we just see this, it's benzene. And if we would do something even as simple as this, okay, you name the derivative that's on there and then call it benzene. So we've got a halogen on there. So very simply put, you would call that what? Name the derivative, chloro, and then it's a benzene ring, so this is chlorobenzene. Okay? And you can also do something like this. Okay? And, okay? Notice it would be a very easy trap to fall into. And you don't always start as number 1 up here. Because remember, we want to give that the lowest number possible. So it would not matter if you started here or started there. Because either one of these could be number 1. It just depends how you want to orient them. Okay? So I think maybe to keep it simplest, I believe that every time you can go clockwise, that's probably the most simplest. And I think you'd probably agree. Because I don't think you'd want to start down here, because if you're going clockwise, that number's too big. Okay? But if we start here and give this as number 1, then this one's number 3. Because if we go clockwise down here, we've got 1, 2, 3, 4, and then 5. 1 and 5 is too big. And I think you would agree with that. But if we start here, then we've got 1, 2, and 3. Okay? Does that make sense so far? Middle, left side, right side, okay? So then, again, you still have to name the derivatives that are on here, and if we call this 1, which we would, you'd go 1, comma, where's your next derivative? On the third one. And then dash, because dashes separate the numbers from the words. And these are referring to what type of derivatives. They're halogens, but it's chloral. But when you have two of them, there's a prefix we need to put there. Okay? And then the only thing we have left is what? The parent structure here, which is benzene. Okay. All right. I don't want to make this too difficult, because how many of you are looking at this already and thinking, I can foresee this in about another week getting really, really difficult? Okay. Awesome. We wouldn't tell a fib, would we? Nah. No. Our noses are growing. No, you don't. I always think of Pinocchio and Shrek too. Say you're wearing women's underwear. Are you? No. Oh. All right. So now I'm going to change this a little bit. One of the very last things that you had seen, even color code it like this a little bit. Okay, I'm going to cover this up. There's one of two ways that you can do that. Remember, the last thing we talked about was it said before the nomenclature system was derived, this would be called, naming your derivative again, which CH3 is a what? Methyl group. So you got a methyl group on what? On a what type of ring? Benzene. So you could call this methylbenzene, which I would not suggest you do, but it's right. A more appropriate term would probably be what? It's wrote down on your paper. That was up on the overhead, sorry. Toluene, toluene, I always say toluene. You can call it toluene. We know what you're referring to. Okay? So I would suggest you call this your toluene or toluene. Okay? And to me, it's kind of like how many of you, during the course of a volleyball game, it's your turn to serve, how many of you feel comfortable, you're starting 10 feet back, you start running, throw it up, and you do your jumping serve? How many of you do that? So is it suggested that you do that? No. So for the same reason, I would suggest that you do not call this methylbenzene. It's just like, you're not wrong for doing that jump serve, but is it a good idea to do? Probably not. So for the same reason, is it a good idea to call this toluene or toluene instead of methylbenzene? Yes. Okay. All right. So now, the same thing would apply here. This nomenclature works. It makes it a lot easier when you use that common name. Because if you are going to call this methylbenzene, well then you got to make sure you're calling this number 1, because you said you want this to be your methyl group, and then this is off on a different number, and it just makes things a whole lot more confusing. But if you just stick with saying, I'm going to call this toluene because we've got a methyl group on here, then the only other thing I got to do is just name where that chlorine group is. But when you do that, you are saying that this methyl group is on the first carbon, and that's what makes it so much simpler. So where's this halogen derivative in reference to this? Which carbon? The third one. So now, all you would have to write is 3-chloral, and then the common name for this, which was what? Toluene. And that's what makes that so much simpler.
Whatever that, I understand that, is dealing with the methyl group connected to the benzene?
That's exactly right. Yes. Again, this is what I would suggest that you stick with.
We don't even have to add benzene to it?
No, because you've already accounted for that right here. Yep. Because when you're saying toluene, it's kind of like using that as a variable that's a stand-in. Okay. So let's not dive into this too deep. Okay. So barring no questions on this, we'll pick up with this again tomorrow with your phenol, your carboxylic acid, and aniline, I believe. And those common names again can be found on the top of page 360. Okay? It doesn't say how you pronounce that. I don't know. Because there's also a shortcut that you can take with this, but I don't want to go driving into ortho, meta, and para shortcuts until we've gotten through all of these. But that's what it's telling you on a little further down on page 360. All right, so we will pick up with this next time.